Welcome back. In today's video, we're trying to determine the expression for v2 of t. Here we have a simplified model to explain lead and lag. And we're given that they v2 of t and v1 of t have identical amplitudes and they oscillate at the same frequency. However, though, the caveat is v2 of t lags v1 by a phase angle of 60. So let's talk about lead and lag. Here we see that the square occurs earlier in time before the circle. So thus we can say the square leads the circle. So the square leads the circle. And notice that the circle occurs later in time. So if it occurs at 0 and the square occurs at -1, that means the circle lags the square. If we move our square to the opposite side of the circle, we can then go ahead and say the circle leads the square because the circle occurs earlier in time than the square. And we can switch that around and say the square lag the circle. By knowing that, we can then go ahead. If we have the amplitude equaling to the same, the frequency the same, we can just say that v1 of t have a phase angle of θ1, and that is 30. We're given that. v2 of t have a θ2, and we don't know that. But we know that v2 of t lags v1 by a phase angle of 60. So thus we can say that θ2 is equal to θ1 plus minus 60. 30 plus minus 60, we get a phase angle of minus 30 degrees. Thus we know that θ2 is 30 degrees. Thus v1 of t is equal to 4 cosine 2 pi. And I can just write that instead of e to the 3, I can just say 10 to the power of 3 times t plus 30 degrees. That's in volts. And v2 of t is equal to 4 cosine 2 pi 10 to the power of 3 t minus 30 degrees. And that's in volt. We can then go ahead and look at we can graph that in decimals. But first, let's look at the cosine of x with an amplitude of 4. And then we can look at the advanced version of that. This is because, if you notice, just like the simple model that we had, cosine of x plus 30 occurs before cosine of x. Thus, cosine of x in this case would be cosine of 30 would be an advanced version of cosine of x. So cosine of x plus 30 would be an advanced version of cosine of x. And if we look at cosine of x minus 30, we see that this is a delayed version of cosine of x. We can then throw away our cosine of x and talk about our reference waveform, which we're given as 4 cosine, amplitude of 4 cosine of x plus 30. And notice that it occurs at -30. So if you should add 60 to that, well, in this case, -60, because v2 of t lags v1 by 60, and if it lags, that means we delay it. And if we delay it, we need to move to the right to delay. If we move it to the right, v1 becomes v2 of t, and v2 of t now delays v1 of t. And that is what we have basically right here. So it occurs at positive 30. So -30 plus 30 is equal to 0, plus another 30 is equal to 30. So there we have it. For this one, it's a little bit counterintuitive, but lead and lag, it's simple. We can just see that v1 of t leads v2 of t. So thus, v2 of t lags v1 of t. And that's it for this problem. See you in the next video. Bye.